So you may have noticed that there is no note sheet today. You may have noticed that there is no note sheet today. So the reason why is because it's honestly the way they wanted us to do the lesson is just too long and drawn out. I'm just going to show you and I'm going to record me showing you. And if you ever need to refer back to it, then you can. But what we are doing today, here's the goal. Let me find my other slide deck. The goal is to use technology to represent data and see how statistics change with the data. So things like how mean, median, quartiles, IQR, things like that, how they change when the data changes. And it's really easy to see that with technology. Now, the technology that I'm going to show you, you can't necessarily use on your unit tests, but you can use on your practice. Just make sure that we're also practicing the normal way too, because you can't necessarily use it on your unit test. I'm recording right now. I'll link it in here when I am finished. And you do have a puzzle piece practice called the effect of extremes practice. Whatever you don't finish in class does become homework. So just make sure we're keeping up with our grades. Check the grades tab in Schoology. It'll take you directly to whatever assignment it is that you're missing. If you were absent yesterday, I will definitely pull you from Monday to take your quiz. The expectation is that you take it the day you return from your absence. So ordinarily, I would pull you from class today just to do it real quick. I think Monday will be better. So just be prepared for that. But know that in your syllabus, it says that you take it the day you return from your absence. So make sure you're checking Schoology, seeing what we do every day. The assessments are usually announced ahead of time. So always be prepared for whenever there's an opportunity to pull you. Now, the technology that we're using, you can find the first one in this week's folder. So go to Schoology. This week's folder will always be toward the top. Under like the general folder, it'll be here. And then find today's date. Here's all the slides that have basically all the instructions for everything every day. And this GeoGebra spreadsheet app is what we're going to look at first. All right, so click on it. I suggest pressing this little button to make it like a bigger screen. Hit continue when it asks you, are you sure? Yes, I do want to go there. So we're going to look at this. And also at the same time, we're going to look at Google Slides because it's more likely in the real world that your whatever job you have will have you use Google Slides or Microsoft Excel, which you guys all have free access to Google Slides. I run out of find Google Slides. Click a new tab, click on your apps, find the one that says sheet. Sorry, I've been saying slides. It should be sheet. All right, and this is really what we use in the real world versus like a graphing calculator. I know in college in one of my math classes, we weren't allowed to use graphing calculators. We had to do all our math in spreadsheets. So again, what I'm about to show you makes it super easy to find the statistics in a really fast way, but you still have to know how to calculate the mean with a normal calculator, how to calculate the median with a normal calculator. So have these two screens up like side by side if you can, because we're going to enter data into both. Now, the data that we're entering is on this page. I'm going to zoom in as much as I can. And here's basically how you read spreadsheets. If I'm talking about cell A1, I'm talking about this cell that I just clicked on in my GeoGebra spreadsheet. So it says that A1, that value should be 7. So type that in and then hit enter and it automatically takes you to the line below it. A2 should be 8. A3 should be 4. And then keep going. A4 is 13, then 5, then 15, then 14, then 8, then 12, then 2. That should be your A1 through 10 is these data points. And then they just couldn't fit it all in one slide, so they broke it apart. So this tells you that A11 is 8. A12 is 13. A13 is 12, and keep going. Next one's 13, 6, 1, 9, 4, 9, and 15. And that should fill up all the way to A20. And you should all be practicing at the same time on your own screen. All right. We're also going to put it in our Google Sheets too. So I'm going to highlight this. So to highlight it, you like click and hold and drag like that. And Control C, that's your copy. Control C. And then go back to that Google Sheet I told you to get. Let me zoom back into that. And then Control V, paste. So now I have it in 2 spots. The reason why I'm showing you both technology is because one, Google Sheets you'll probably use more likely in your real life. It's also more user-friendly in my opinion, but GeoGebra just does more. Like it can make you a box plot, whereas Google Sheets can't. So there's pros and cons to both. I'll just show you both. Now, what's cool is that you can enter stuff into another cell. So like here's where I'm just going to keep my data, but you can enter stuff and basically have it do operations for you. The way that you do that is you have to press equal first. And GeoGebra is like less user-friendly. Say I want to find the sum of something. I type in sum, but it has to be a capital S for some reason. Yes. The value, it was 15. You're welcome. All right, so you put sum, and I put a parenthesis, and then both parentheses pop up in the GeoGebra one. And what I'm just going to do is I'm going to highlight, and I hate that it doesn't show my highlight, but I'm going to highlight and drag and release at the A20. And then it should have, nope, it didn't. See, that's why I'm also showing you on Google Sheets. Let me try again. So highlight, drag, release on the A20, and then enter. Now it pops up. So the sum of my data is 178. I could do the same thing on my Google Sheet. I can press equal. This time, it doesn't matter if you capitalize sum or not. You'll know if it's a function that it can do if this little menu pops up. So sum, parenthesis, and then it kind of helps you out. It tells you to enter your values. Since I already have my data here, I'm just going to highlight it. And I like that it like color codes it so that you know. But also look how it writes it. It writes it as A1 colon A20. So you don't even necessarily have to do the dragging. If you wanted to, you could just write sum, parenthesis, A1 colon A20. All right, and then hit enter, and that's your value. Another reason I like Google Sheets, and I know it's hard to see with the clock right there, but when I click on the cell, I can see what I did. So I know that 178 is a sum. If I was doing it over here, I might like have to title it just so that I know what it was. But then when I hit enter, I can actually see what was written in there. I still like Google Sheets better. Questions so far? All right, now the rest I'll show you in here, but it can also do it in here too. So like I can also find my mean, my median. I could find my quartile 1, my quartile 3, because what's quartile 2? Good. So quartile 2 and median mean the same thing. So I'm just going to put a slash in there. And these are just titles so that you know what I'm doing. All right, the actual coding I'll put right here. So like click on the cell. First, we're going to find the mean equals. But notice if I type the mean in Google Sheets, it doesn't recognize that function because no little menu pops up. What's another word for mean? Average. It does recognize average. All right, because I know because the menu pops up. So average, parenthesis, you can start putting in your values. Is it a question about this? Then hang on. Close the parenthesis. And now it gives me the average of my data, my mean. You can do the same here, which I'll show you in a second. But I like this one. It's just easier. It's more user-friendly. So you can use this to check your work. Can't use it on the unit test though. But this will just make it faster when we start adjusting our data later to see how it changes. All right, your median, you can just type in median, parenthesis, highlight your values, or type in A1 colon A20. Your quartile 1, you can put equals. That's how it knows to do something. Quartile, if you type it wrong, it won't recognize it. Now, when you put the parentheses, it says what it wants. It wants first your data, comma, then whatever quartile number it is. So I'm going to highlight my data, or I can even just type in A1 colon A20. Put in a comma. Since it's quartile 1, we're going to put a 1, close parenthesis, enter. That's my quartile 1. Do the same for quartile 3. Adelie, you can go fill up your water bottle now. I'm just going to highlight this so you can see it. What's the value of my quartile 3? More than one person, please. You all should have found it. All right, what's the value of my quartile 3? You guys should be practicing in your own. Thank you. 13. If you're getting something other than that and you're not sure why, then let me know. But when I click on it and you can look under, or I guess you can't because I have this menu up. But when you click on it and you look up here, I know it's hard to see with the clock, you should see exactly what you typed, which it wants the data, comma, whatever quartile it asks. Questions, comments, concerns? So now look what happens if we adjust some of this data. So the reason why we're even using technology at all, because I know you can calculate all of this by hand, is to make it just faster when we're talking, when we're getting questions such as replace a 15 with a 100. Before I even do that, what do you predict will change? Anything? If I were to replace one of my data values with the number 100, what, if anything, do you think will change? Which number? Would my mean change? Would my median change? Would my quartile 1 change? What do you think? You think it'll all change? Anyone think something different? All right, so let's see. And you can do the same on your screen too. Change that last 15 to a 100 and then hit enter. Because this is coded for A1 through A20, it should automatically change on its own. What was the only thing that changed? The mean. So even without calculating it, I could tell you that the mean is probably going to change if I add a number that is way bigger than the rest of the data. Doesn't that make sense? Wait. All right, because what's the formula for mean? I shouldn't have just one person listening, and the longer it takes, the less time you guys have to work on your practice, the more homework you have. So what's the formula for the mean? Yes, Davin. The sum of your data divided by the number of values. So did I change the number of values in my data? No. It's still the same, right? I changed the sum of my data and I changed it by a lot. So it makes sense that even without even doing the calculations, I know the mean will probably increase. But why didn't the median increase? Why didn't the median change, Camille? Because since one of the values is bigger than everything else, the median is what is in the middle. So the 100 is into the bottom, so that does not make any difference. Because what value did I change? 100 from 15. Good, and 15 was my highest number. So if all I'm doing is replacing the maximum, does that change the order of anything? No. Now let's see what happens. Let's make that 115 again. All right, so we're back to normal. Let's see what happens if I change that 100 to say like a really small number, like a 1. And then I hit enter. Everything changed. Why did my median change? Or did it? Let me check again. Yeah, it did change. Why did it change? Yes, 7. No. Well, yeah, so median, you want your numbers in numerical order. So if I switch my highest number with a number that's like a lot smaller.
So it's because the one is smaller than the 8, right?
Correct. Because it's so small, like I'm really shifting everything over, right? It went from being at the end of my data to now at the beginning, and everything shifts over. I had 20 values total. That means I have how many numbers in the middle? 1 or 2? 2. So I would have to take the average of them. So if everything's shifted over, then the numbers in the middle must have changed, which means that my median changed, my quartiles changed, all that good stuff. So you can clearly see it when you actually type in all the data, do the calculations, and then adjust it, like play around with it. Right? But if you're adding a really big number or you're adding a number that changes the order, you should expect there to be changes. Questions, comments, concerns? All right. In Excel, you can do things like insert a chart. Let me make this back to what it was, 15. You can insert a chart, but it looks like the only one you can do, so you'll have to highlight your data, is a histogram. I mean, there's other types, but not of the type that we normally talk about. So like, here's a histogram of my data. They separated it into intervals. I kind of don't really like those intervals that they picked. I'm sure there's a way to customize it. So that's where, in that case, the GeoGebra spreadsheet might be better. All right, so then if I highlight this data and I press this histogram box, we're only doing one variable analysis in this unit. Here's my histogram. All right, I can adjust the intervals by sliding that thing. So if I make the intervals smaller, I have more bars. If I make them bigger, I have less bars. If I press this little button, it says show statistics. Then it gives me this box of data, and look, it tells me my mean, it tells me my minimum, my Q1, my median, my Q3, my maximum. So it's pretty cool. And there's a way to do other graphs. I kind of forgot how. Oh, here it is. So you see this little drop down? It can even make you a box plot. So now if I play around with my data, let's see if it changes. I haven't tried that today. Look, it changes it. I added a 100 instead of a 15. And look what it did. Why is this not part of my box plot? Why is it like separate? If it was part of my box plot, like it normally is, it would make this whisker super long, right? Way far away from the rest of my data. The reason why I did it like this is because it's clearly an outlier. It's way bigger than the rest of the data. So they chose not to include it. I know there's a way that I can like make it include it. Show outliers, and now it includes it. All right, so that's kind of cool for this purposes, seeing how your data distribution changes. So if you included it, you can see like, is this box plot symmetrical? No, it's skewed. If I look at my dot plot, it's skewed again because it has one way over here and like a big gap. If I change that back to what it was, now it's starting to look like a normal box plot or dot plot, and you can see the distribution. So questions, comments, concerns? All right, John, you can go now. Now, all the like notes that we really need to take, hopefully you took that in and can use it. Otherwise, you don't have to. You can also calculate everything by hand. But now just look at your cool down paper. That's why I told you to get it out. We're going to answer these questions, and that's really it for our notes. So for lesson 9, that cool down, because we basically combined the lessons. When it says what is the mean and median for the data, well, what is it? Good. So it tells you in the chart. That's for the mean. And then for the median, it was 51. For number 2, it says how many values are in the data set on our cool down. On our cool down. So that's hard to see, right? If I go back and show you on the one we did today, we know we did 20 data points today together. So you can see from here that the N tells you how many data points. N is like for number of data points. So back on our cool down, how many values are in this data set? 100 is correct. All right, that is what tells you the number of data points. Now, does it, for number 3, it says, what is the interquartile range for the data? Do we have a separate little box that says interquartile range? Do I see an interquartile range on here? No, but we learned how to do it yesterday. What's the formula for interquartile range? Q3 minus Q1. But, and look, it does tell me my Q3 and my Q1. So my Q3 is 77, my Q1 is, what's 77 minus 23? Good. All right, and the reasoning could be this. All right, that's the formula. Since we can clearly see it from the picture, then that's all we need to do for that one. Let me take a picture. And then we'll scroll down. All right, now lesson 10, which we combined in this, is about how extreme values change your data. The reason why we incorporated the technology, so like we put the two lessons together, is because it's easier to see when you have technology to do that for you. So the first question, let's talk about the distribution shape. Is it uniform? Is it symmetric? Is it bell-shaped? Is it bimodal? Is it skewed? If we had to pick any of the options, we would probably say skewed. All right, we know it's definitely asymmetric. If it was skewed, what direction would it be skewed? Right skewed, good. So then just kind of keep that in mind. That's more important than what the actual question is asking. Asymmetric, it's skewed right, we can say. What this question is asking is the mean greater than, less than, or equal to the median? Personally, I say just like use your technology and figure it out. Calculate the mean, calculate the median, and compare the two numbers. The answer to this is greater than. All right, because if you were to actually work it out, these numbers are, even though there's fewer in this area, it's not few enough to be like that, that the median's greater. All right. Our middle of our data would be like somewhere over here, but because these numbers are so big, it would change the mean. The mean ends up being greater than. Down here, how would you describe this distribution? It is uniform. Any other words? So when it's symmetric and uniform, even bell-shaped, anything that's symmetric, then the mean will be the best measure of center. When it's asymmetric, I want you to write what I'm writing. When it's asymmetric, the median is the best measure of center. Median is best measure of center. That is more useful than what it's actually asking. What it is actually asking is the mean greater than, less than, or equal to the median? What do you guys think? It's going to be equal. If it's uniform, it's going to be equal. If it's symmetric overall and you're trying to figure out which measure will best represent it, it's going to be mean. So questions on anything we did today? Does it make sense? Is it? So the technology is helpful. Like if you're doing quick calculations with your practice, you still have to know how to like calculate mean, median by hand, all the things by hand, which we've covered before. So that gives us about 15 minutes to work on our puzzle piece practice so that we don't have homework. You can use this technology, or if you want to just do it the old way, that's fine too. This is a great time to ask me questions and to make sure that you don't have homework this weekend by getting it done in class. Good? All right.